Hi, everybody. Welcome back to the DAC Pavilion. So our next speaker is Eric Berg from Microsoft. He's in charge of AI and ML for design verification. So it should be a really interesting talk. Personally, I'm looking forward to hearing it. So thank you.
Hey, good morning. I had Tom asked me before I came up, or right as we came up here, how I wanted to be introduced, and I had a very live bio that ChatGPT had actually written for me. If you ever want to feel good about yourself, you feed your resume into ChatGPT and say, introduce me like a marketing person would. So ChatGPT wrote my slides as well. I fed it in some text and said, give me a narrative, organize this for me. And then I said, I'm also an engineer. I'm not always sure how to kick things off. Can you give me an introduction? And ChatGPT said, there's 3 ways you can go. You can say, try and be thought-provoking and say, imagine a world where your most complex silicon design can be realized through generative AI. Okay. There was the inspirational where we say, ladies and gentlemen, we stand at the precipice of a new era of hardware design enabled through generative AI. And then the third option it said was, you can also just tell it, if I had full editorial control, I would have written better jokes than you. So this, we started this as soon as ChatGPT was released in December, I think it was. I went and started playing with it, and my first instinct was to grab the UVM Candy Lovers tutorial. How much of this can ChatGPT do, right? If I start describing it in English language, how close can we get? And some of it was good, some of it wasn't, but you could see that there was something there. And so I fired off some emails to people, and I said, guys, the world's kind of changed. We need to figure out how we're going to leverage this stuff, because I think I see how we can get rid of a lot of the menial tasks that we have to do. So we got a bunch of us together, and we started hashing out what the vision was going to be. What are we going to organize around? We can't just go off and write a bunch of little Python scripts. That's cute, but it's not super useful for getting silicon out the door. And so I arrived at this. I said, you know what? I want to be able to generate my RTL modules from just a written English language text. I want to be able to build formal test benches around each one of those. I don't actually want to do any kind of input. I want ChatGPT to understand my RTL and just build my formal benches around my module, so I don't have to worry about that. At some point, I want them to stitch them all together for me. Maybe I have a section of my spec that says A is connected to B in this way, but I don't want to worry about how to do it. I want that done for me. And as we scale up, eventually the state space blows up, and I can't keep doing formal around all these interfaces. I want it to build my UVM bench, so I don't have to worry about that. And random testing is a little bit annoying as well. So what if I just had it what if I just built a feedback loop in there so that I was leveraging ML and AI, not necessarily ChatGPT, but other models, to be able to go ahead and build new stimulus, measure the output in my coverage, generate new stimulus, measure the output in my coverage. Look at this. I got logically clean silicon all through generative AI, right? So as you can imagine, there were a number of people who were skeptical, a number of people who didn't like the style that it was written in, but we're doing this in production right now, right? There are components of this that are actually in my production development stack. So a lot of the experiments that we did were around RTL module generation, RTL assertions, formal properties for design exercise. We did test bench components. We refactored a lot of our existing libraries. We wrote unit test environments for a lot of our firmware that previously did not have that. We went and talked to the silicon design guys. We said, hey, we can do RTL modules. They said, well, I mean, that's nice, but writing RTL, that's like the fun 2 weeks of the project. It's everything else that sucks all of our energy. So we went and we started working with them on their tool command lines. And all of a sudden, we can start teaching ChatGPT. This is the way that once we actually have RTL in place, we can go ahead and we can start running it through the full design development stack. There's some restrictions we've run into along the way. We're not actually allowed by our legal team to use the RTL that's generated into our production environments. But we've done all this work with the publicly available GPT model. We're not doing any fine-tuning. It's the same model that's out there. We have a version of it in a secure environment so that we can actually use our production data without worrying about any kind of leakage into the public domain. And this is all going on right now. So every presentation I've seen here so far has had at least one obvious slide. This is kind of my obvious slide. Complexity is going up. There's more demands that are placed on our teams. There's more stuff to verify. How are we going to be able to manage all this? This slide, though, was one that I saw at the Synopsys Snug this year, and this was not something that was obvious to me. We're not graduating enough people to meet the demands of the industry. So we're going to still be expected to get our work done in the future with less people. How's that going to happen? And even forgetting about far into the future, I'm thinking about back through my entire career. I have never been on a project where when we were in the scoping phase, my only job was to kill features. Verification management, we don't have the heads. Kill as many features as you can. I don't want to be in that space. I want to be in the space where we enable all the features for all the products, right? So this is what we see with generative AI. We can go ahead and we can expand the scope and the scale of every single engineer to be able to meet these kinds of demands. Everywhere you look, there's headlines about AI and ML. We know that EDA companies are leaning into this because this is the only way that we're going to be able to improve our productivity. When I sent off that first email, but I got to acknowledge, there's a lot of fear in the industry too about people being displaced by generative AI. I don't think that's the case, but it permeates the whole culture. There's a lot of anxiety, and even the leader of our tools organization, when I first sent him that email about how the world has changed, he wrote back, he said, "This is terrifying." I said, "It's not terrifying. I'm never going to have to write coverage again. I don't want to do that, right? This is kind of liberating in many ways." So ChatGPT is just the next step. It's the next evolution of this AI and ML being incorporated into our EDA tools to enable us to do more. Don't be afraid. It's going to be good. Looking back through history a little bit, technology, it tends to accelerate the productivity that we can get, and not just for engineers, but for people in the world. I looked back at some early articles about personal computers, and it was the same concerns back then. Everybody's going to get laid off from personal computers, right? That didn't happen. It enabled many, many new workflows. It enabled a lot of new ideas to flourish, companies to be built. You think about when we moved from command lines to mouse control, it improved accessibility and velocity to a lot. More people could use computers at that point, right? You didn't have to be totally tied in with how command lines work. You just point and click. There's a total democratizing force to be able to enable people more access to compute. And then in the design space, of course, there's the synthesis tools and the automatic place and route that have replaced some of the more tedious work that people have done and allowed us to move more quickly as organizations. So there's kind of like there's the big wins in terms of building verification collateral, but there's other wins too in terms of by leaning into this generative AI stuff. There's a lot of data out there about how people work, when we're productive. We peak before noon. If you think you do your best work late at night, you're wrong, right? We peak before noon. That's just the way we're wired. And you're usually only good for about 4 hours a day of really complex work, right? The rest of the day, you're not on your best. And the bandwidth that you have during that 4 hours a day where you're doing, where you want to do complex work, that gets eaten away by menial and repetitive tasks, stuff that you don't actually want to do, right? When we first started setting up those experiments, there were 2 ways that I told people you could start doing your experiments. One would be either in furtherance of this vision, pick some component on here and do experiments around this, whether it's the formal test benches, whether it's the RTL modules, whether it's the UVM, whether it's generating the collateral or the feedback loops in the MLAI. And the other thing that you can do experiments on, and so some people would say, well, I'm not really sure what that's supposed to look like. I said, okay, well, here's another way to think of it. What part of your job do you hate? What do you never want to do again, right? What's the stuff that just frustrates you? What do you push off to the end of the day, right? And so that was another avenue. People very quickly thought, oh yeah, there's 5 things I never want to do again. These are the 5 things I hate about my job. And so we want to get rid of those. As engineers, we are in the idea business. That's what's fun. That's why I'm here. I want to do new things. I want to bring new products. I want to bring new features to the world, right? And another thing, meeting schedules. Like my calendar occasionally starts looking like Swiss cheese with just small openings where I might actually be able to do something productive, right? It eats away at your ability to do the work that you want to do. Now, it doesn't have anything to do with generative AI, but I would offer as kind of a life hack. I think twice a year, everybody should go to their calendar and do a Control-A-Delete, and you'll find out how many of those meetings that are on your calendar you don't actually need to be at, right? So you'll get a lot of your time back. So here's how generative AI has helped. It allows me to accelerate the implementation of my ideas as prototypes, right? I might have a great idea, but if I have to pull together a work stream with like 6 people, that means I have to get their buy-in, I have to get their availability, I have to find times during the day when they actually want to work on it. Generative AI gives me access to expert knowledge on my own. I can build prototypes in a single day that would have taken me a month to organize people around. I code faster with higher quality and smaller time windows. You know, right now, if there's just a small sliver of time in my calendar between meetings, before generative AI, I would have been like, I don't know, maybe I'll get a coffee, maybe I'll talk to Joe. I can't get anything done in a half an hour. I can write a lot of code in a half an hour with generative AI. A lot of really high quality code. And it allows me to make mistakes, it allows me to iterate, and in a half an hour I can get stuff done. At the end of the day, it happened to me just last week, I was like, oh boy, it's 4 o'clock. I gotta go pick up my kids at 4:30. There's not a lot of time, but you know what? There's that one idea that I had that I wanted to get the prototype for in a half an hour. I can go ahead and I can bang that out by using generative AI. I took some of my libraries that I had written for one of the tools that we had, and I gave those to ChatGPT. And they were all protected by unit tests, so I wasn't worried about if it was going to introduce bugs into it. But I gave it to ChatGPT and I said, optimize this library for performance, right? There were a lot of like kind of big data algorithms that were in there, and I tried my best, but it's not my specialty. So I gave it to ChatGPT. It spit out new code. Every single function was between 2 and 5 times better, 2 or 5 times faster, and it passed all of my unit tests, right? I saw in there were new language features in Python I didn't know existed. There were open source packages it was referencing and importing that I had no idea existed. And the amount of time it takes me to go and find that information, understand how to use it, interrupt my coworkers, see what their experience is, gone. I can just rely on ChatGPT. Debugging, right? There's the rubber duck debugging. You never find the bug. You can look at it for hours. You're never going to find it till you go and you talk to a friend and you're like, oh, idiot, okay. That's my ChatGPT. Stuff's not working, I feed it in. Why is this not giving me this answer? Why is this not working the way that I expect? Why is this giving me a stack trace? Like that, done. So, there's the big ideas around verification, but then there's also just the quality of life as design and verification engineers that generative AI is going to help us with. Enabling teams, maximizing your influence. So I'm a huge believer in leaning into my experts, right? And I want to be able to have my experts, whether they're senior, whether they're junior, whatever they are, I want to have access to all of their knowledge all the time. Now, of course, they don't want me in their cube all the time. They don't want me interrupting them all the time. They don't want to be, have a barrage of emails coming to them all the time. But what we're able to do is we're able to build these shared contexts that we leverage with the ChatGPT in order to be able to spread their knowledge so that other people get access to it when they're doing their work, when they want to generate new code. I have access to the expertise from the formal person. I have expertise to the knowledge from the UVM person. I have access to the expertise from the machine learning person, right? All at my fingertips, whatever time of day I want to spin one of these things up. But coding practice. Another thing that I hated, code reviews. It's just so tedious. I don't want to do this anymore, right? Either I want ChatGPT to do my code review, or I want to start building our code from shared context so that there's already a style that we've agreed upon, and everybody is going to be generating code in the same way because it comes from ChatGPT. Making collaborations more interesting. We had a group of people in our work stream that were across a number of different subgroups in our Silicon organization. And we're trying to prioritize what are the first large projects that we're going to attack with generative AI. Where do we need help from the tools team to make sure we can get these flows into the right parts of our production? And there were 6 or 7 of us there, and we were sitting there brainstorming for an hour. And nobody wanted to take minutes, so we just kind of recorded the whole thing in Teams. I took the entire transcript from Teams, dumped it into ChatGPT, and said, can you identify the 3 best areas for collaboration that's going to meet the needs of all 6 organizations? spit it out with justification for each one of those, the benefits that are going to be supplied. I can send that out to those teams. I say, guys, can we agree on this path going forward? Done, right? So it's, beyond the code, it's finding the commonality between what people are working on. It's finding, how do we have the shared effort? How can we talk about interesting things instead of having chalk talks on like how to grind through execution tools? Nobody wants to do that. It's a waste of our time, right? That's not what we're paid to do. That's not the fun part of our job. I don't go to bed at night thinking about, oh boy, I can't wait to run that tool stack tomorrow. That's awesome. No, I'm thinking about how do I, get this feature into reality? How do I make this new idea I've got? How do I present this to the design team and the architecture team and get this into the project? Changing how we work. It hasn't been. It's not a case of we can just give our existing text-based specs to ChatGPT and say, hey, just take this and do what you want. It's not like that. You have to kind of reformulate the problems. You'll find plenty of tutorials online that talk about the right way to talk to ChatGPT in order to get what you want out of it. I haven't given you a recipe for how we did the formal stuff, or the formal and the vision slide in the beginning, but we don't have any novel techniques, right? All of this stuff, the things that I've learned from LinkedIn tutorials or from YouTube videos for people who are just talking about using generative AI. And we're just using the standard publicly available model. But it has forced us, once you start to hear how people are talking to ChatGPT, it's forced us to think about how we're going to frame the problems a little bit differently, right? An example I'll give you is, 10, 15 years ago, if you were writing a script, it was perfectly acceptable to have functions that were 30, 40, 50 lines long, right? That's just kind of how you wrote these scripts to get stuff done. But nowadays, with common software practices, we don't accept functions that are 40 lines long, right? Things have to be 3, 4, 5 lines long. Things have to be fully under unit test. Now, RTL modules, it's not going to be 3 or 4 lines long, but it shouldn't be 5,000 lines long, right? So if we can start to think about how to make our RTL more modular, to be able to fit into smaller contexts so we can leverage the ChatGPT, all of a sudden verification collateral starts to fall out pretty quickly. Again, and then rethinking how we write and represent the specifications. It's interesting working with ChatGPT. It's not a deterministic thing. I can't necessarily tell you, you must write it this way. There's a feel that you kind of get over time, but seeing the results that you get. And it takes 2 or 3 iterative loops, and we're all smart people. You'll figure it out, but it will be different than the way that you're formulating problems. It will be different than the way that you're writing your documents right now. Challenges in generative AI and hardware design. So generative AI, it is a stochastic process. I can't guarantee that what it gives to me today is going to be the exact same thing that it gives to me tomorrow. I can influence what it gives me, and I can influence it on some days more than I can influence on other days. We don't quite understand why days of the week has had an influence so far, but that's certainly something we have observed. But you can point it in a direction, and if you're willing to iterate 2 or 3 times and give it a couple shots at it, you can get where you need to be. The large language models in ChatGPT, they do hallucinate very convincingly. There was a particular website I was trying to post to, and I wanted to put a link into my post, and I couldn't figure out how to do it. So I was like, well, let's see what ChatGPT can do. So I went to ChatGPT. I said, I'd like to insert a link into my post on this website. How do I do it? And it gave me a step-by-step approach. First thing you do is you click here, you hit the link button, you paste your link in there, everything works. I followed all the steps all the way up to that link button, and it wasn't there. And I kept looking, and I was like, is my software out of date? Like, how is this, what's going on here? What am I missing? I don't understand. I had a friend come over and look. They're like, yeah, no, there's no link button there. So I went, okay, well, forget this. Let's go to Google. First result on Google was you cannot insert links on this by posting on this website. And the second link was somebody on Reddit saying, ChatGPT lied to me about being able to post links on this website. GPT users can get stuck in iterative loops. I got stuck in one recently with DALL-E. So on this slide, I didn't like that I was presenting an image where the robots were bigger than the people. I wanted to have the robots more of a helper, so I wanted them to be kind of smaller like a puppy. I can't get it to make robots smaller than people. I'm not sure what the message is, but I started off, and it gave me this picture, and I was like, well, can you make the robot smaller? And then it made the person scale as well. And then I said, well, what if I just ask for a person? So it would draw a person. And I said, now give me a robot with the person that's smaller than the person. And it brings the robot in, but it wasn't quite smaller than the person. So I started with the robot, and then the robot was bigger. And I said, well, what if I had a robot on the shoulder of the person? And then you had a person with an 8-foot robot on his shoulder. And then I just kind of gave up. So I won't say it has a personality, but there are some corners you can get stuck in. And of course, hardware design and verification, it requires precise and deterministic answers, right? We're not writing poems. We're not writing short stories where there's a lot of ways that things can end. At the end of the day, we need to be able to know that we are actually verifying a design. We know that we've got full coverage. We know that we're exercising all the potential scenarios that we would expect to find in the design. And so it takes a little bit more guidance, a little more finesse to be able to make sure that we're getting that. I like to build in kind of redundancy. So if you're building formal verification assertions, then you've got to make sure you've got the coverage to go with it, or maybe you've got the code coverage to go on top of that. So there's checks that you can build into these things to give us what we want as hardware verification engineers. So the call to action here, we need to prioritize areas of opportunity. If there are EDA folks who want to come and work, you've got ideas for how you want to be able to collaborate with us at Microsoft, by all means, come and talk to us. We want generative AI into all the existing tools. Obviously, we're trying to do it as much as we can with our scripts and our organization. And it would be a lot nicer if it was in the rest of the tool suite that we're currently using. We need to figure out some of the legal issues on ownership, and this is not something that I'm going to be involved with at all or even know how to resolve, but it would be awfully nice if we could generate our RTL and use that in production, but we're prohibited from that right now. I would encourage, I've talked to a lot of people at this conference whose companies won't enable them to use ChatGPT in their work. And first I was a little bit horrified because you can do it certainly in a secure Azure OpenAI environment. But part of me also said, well, if you don't want to get on board, that's fine. I'll extend my lead a little bit further, and maybe I can relax a little bit more. So take your time. But in all seriousness, we do this with production code, right? We're not worried about leakage. It's fully secure. We don't have to worry about, when we first started our work, we could only work with, we're doing the initial experiments before we had our environment. We could only work with open source designs, and we had to use a lot of abstraction on what we were feeding into ChatGPT, so it required us to, it added friction to being able to use it, because we had to abstract things, we had to get our answers, we had to unabstract them. We had to be careful about what things we were pushing up there. Like, just get a secure environment, just start playing with it, just start using it. I think what the level of innovation we're going to see here at DAC 61 next year around generative AI, once folks are actually able to play in secure environments, I think it's going to be stunning, right? So in conclusion, generative AI, it's allowed us to scale. Engineers can tackle more interesting, challenging, complex work. It allows engineers to kind of work across domains. I was talking to a professor here from NYU, and he mentioned that he would love to be able to enable biologists to build their own chips. And biologists are not chip designers. They're not chip verification engineers. They don't know anything about that. But they know about biology. If we can democratize more of this knowledge, if we can make things easier and more accessible for people that have ideas from outside our domain, think about the scope and the features and what we can enable as an industry. The future of hardware design and verification, it's being transformed now. Like this isn't one of these things where we're thinking about it. It's in our production stack. We're doing it now. We're 100% leaning into it. I had conversations with friends at EDA companies about the next collaborations that we're going to do to be able to mainstream more of this kind of work. Don't be afraid of it. Lean into it, leverage it, play with it, and I look forward to seeing what you guys can do with it in DAC 61. Any questions?
Thank you very much, Mirja Stan, University of Virginia. I guess from an academic perspective, and you, when you hire the next, young engineer, how is this going to change the way you look for skills? Because now, presumably, having the actual specific skills is going to be maybe less important and more important to be creative. But, how are you going to navigate this, change?
Yeah. So this has been a tension we've had in our hiring for a while. My management, they look for hardware engineers. I don't want hardware engineers. I want people, I think I can teach hardware engineering very easy to people that have other skill sets. So I tend to look for software engineers already anyway. The short answer is I don't know, but I want people that are just creative more than anything else. I look on resumes, I see, what do you do in your spare time, right? What were the projects you did in science fair as a kid? Like, what's your how do you demonstrate the curiosities you have? Because this is all about, there's not a formula for using generative AI. There has to be an inherent curiosity. There has to be an ability to play and explore and to be able to, be okay with being wrong. And so I don't know, but this is gonna, I would say, broaden the field, because there's certain things that we don't, can be done for us, and we just need smart people that have, broad curiosities.
One question is, when you're using ChatGPT, how do you make sure your data is secure?
So on the publicly available one, you can't. In our Azure OpenAI, I just wait for the legal folks to say, yes, you can, and then I'm covered. So if legal says yes, then I go. Outside of that, I don't know how to assure it is or it isn't, yeah.
How are you working with the current generation of EDA tools in your organization, and what kind of methodologies are you bringing in place in terms of bringing generative AI into the flows and best practices? And I also would like to understand what kind of problems you found in applying, right? I mean, is it like a full dependency on generative AI? Is it a hybrid, methodology? And what kind of insidious bugs and issues that you've seen, like gotchas, so far, right?
Yeah. So right now, I'm not sure. There's not much of an overlap with the existing EDA tools that we're using. A lot of this is because it's so new. A lot of our stuff is homegrown. But we are certainly in conversation with them, and they're aware of what we're doing, and we're asking for maybe more robust versions of what we're doing in the current tools that we're using. And you asked, the other question was, what kind of bugs are we finding? So I'm struggling to answer that question. There's certain things about what generative AI does, like the collateral that it builds, where it may not be 100% right, but it's not necessarily a bug, because I can understand where it's gone sideways. I can understand the parts of the syntax that it doesn't quite understand, and then I can kind of I can guide it in those directions, and I can eventually get to where I want to be. So it takes playing with, but we're not at the point of counting bugs in our generative AI collateral yet. Yeah.
Hi. Great presentation, thanks. I'm running a company that is doing AI-based debug. Do you see a day where we don't need verification as we know it now? Or maybe we need to find generative AI bugs rather than people bugs?
Yeah. Well, I'm sure we'll use generative AI to find the generative AI bugs. So debug is something that is very near and dear to my heart. And I don't necessarily, I'd be very curious to speak with you after this. I'm kind of anti-AI in debug, believe it or not. And I think there's other methods that we've employed and other tools we've worked with EDA vendors to build that I think have met our needs more directly. But you could certainly see a world where verification engineers don't do a lot of what we normally do now, but we still do a lot of the debug. I mean, debug, there's a lot of nuance and detail in debug that I'm sure you've seen. It's very, very difficult to get that right. And I firmly believe that even if the AI debug tools are right 90% of the time, my verification guys are going to say, this tool sucks. It was wrong 1 out of every 10 times. It's wasting my time. I'm like, yeah, but it saved you 90% of the effort. No, it was wrong once. I don't want it. So I think there's, there's issues in terms of getting that to the level of quality before people are going to fully lean into it. But I do want to talk to you because I'm curious about how you approach the problem. Yeah.
Hello, my name is Stefan, and I'm a PhD student at Georgia Tech. What are some good academic research topics that you want to see have research done on? I mean, there's a lot of good research on source code modeling, but even then, you can even apply this to like harder problems like implementation and things like that. So,
What are some good research areas for academics?
that maybe, like in your opinion, that you want us to work on or see.
Anything that helps me make my silicon faster.
Okay.
That's it.
Okay.
Anything that reduces my effort in order to get logically clean silicon.
Okay. So faster time to initial design.
Yeah. I mean, the number of features that we've killed just because we don't have heads and resources to be able to do it. It's just it's sad. And I don't want to kill features. I want to enable features. So if you can offer us an opportunity to be able to get there faster with our with the current team that we have, yeah, we're listening.
Thank you.
Yeah.
So very often, I believe, if you ask ChatGPT the same question at different times, you might get a different answer.
Oh, you will, for sure. Yeah.
So when we use this for EDA, I think you have to solve that problem, or at least get to a flow or a methodology where you can be deterministic and you can expect a kind of predictable milestones and goals, right? Is there a flow? Is there something being done to make it more deterministic?
So I don't necessarily need the same result every time, but I do need the same functionality that's compilable, right?
Correct.
I don't care about style.
Yep.
And I've shown results from different days to people, and they'll say something like, "Well, that's not the way I do it, but if it's free, I'll take it," right? And so, and we're pretty good at getting correct functionality that's compilable. It may not look the same today and tomorrow, but the essence of what you're generating is pretty consistent.
So is there some kind of a flow that makes sure at least the result is acceptable in a deterministic way? So
Yes.
something like,
Yes.
I need to do this kind of prompts.
Yes. Short answer is yes. Yeah, there's ways to do that. I can't give you all of my secrets. I feel like I've probably got like a 1-month lead on some of the folks in here, and I want to keep it. But short answer is yes. And I think if you go and you just kind of look at your workflows and you think about how you're actually generating the collateral and the requirements that you have before you're going to accept it, I think the solution falls out. Yeah.
Hi, working in the semiconductor company, the biggest concern is security. So maybe I missed the early part of your talk. So if can you remind that if you have any research direction for maybe federated learning or maybe the clonable ChatGPT or fine tuning, that kind of thing?
So we don't do any fine tuning, so I don't know about that. And some of the other stuff I didn't fully understand. So we can talk afterwards and you give me more details to help me understand.
Okay, thanks.
Hello. Good talk. I'm a PhD student at the University of Alberta. There's an age-old phrase, there are no free lunches. And you're saying that you're using this generative AI, you can get from point A to B quicker, you can not have to ask so many features. What do you think, in your mind, spending so much time with this, is the biggest kind of cost in that sense?
The biggest cost?
I'm saying there are no free lunches.
Sure.
What's the cost using this approach in your mind?
The cost is my blood pressure is lower. I get less frustrated. I'm a nicer coworker. We started off with our initial experiments, and I think there's some behaviors some best-known methods that we've developed to help us be successful as we're writing code and building hardware that we've kind of had to unwire a little bit to be successful here, right? Some of our first experiments with building, I'll pick on functional coverage. With building that, when we got done creating the collateral, we looked and we're like, well, yeah, we did it with generative AI, but it took us same amount of time as it would have taken to just kind of write it. So did we really win? And then we looked at it and we're like, well, we wrote our prompts in this way. What if we backed off? What if we got sloppy? We still got good stuff. What if we got sloppier? We got good stuff. we got really sloppy with the prompts that we were giving, and we still had compilable, exact functionality match that we wanted in our coverage. So the lunch is getting pretty close to free on some of this stuff, right? I mean, I get ideas at just weird times, right? And sometimes I either have to kind of excuse myself and go write things down, or it's in a situation where there's nothing I can do about it. It was a nice idea, but it's going to vanish into the ether. I do little voice memos to myself every time there's an idea. I get into the office, I basically take that voice recording, give it to ChatGPT, and I've got my answer, right? So it's pretty close to free outside of the 0.6 cents per token that you have to pay for ChatGPT. In terms of effort, it's getting very cheap, right? So.
Okay, thank you.
Yep.
Hello, I'm a PhD student, and I'm curious about if there's any comments to the educational part, because as you know, the younger engineer come from the schools, right? Mm-hmm. So we grow up without the AI's help, and so we have to increase our own personal ability to be an engineer. Yep. But if those ability becomes part of the tools or models or AIs, and how will it impact educational stuff, and what do you expect the new younger engineer to have? And if they relies on the AI tools, and one day if, the AI tools no longer available, or it changes, or you are in a situation without internet access, and how will you feel like the new students have to, the ability of that?
I suspect that those students are going to learn skills they're going to have educational experiences that we can't quite dream of right now, right? There's going to be a breadth to it because of what this kind of stuff enables. I was talking to Mohammed, I think his last name is Kassim from eFabless, and he's talking about how the average age of the people that are building chips on their platform keeps coming down, right? And when I originally started playing with ChatGPT, I said to people, hey guys, in 5 years, you're going to see kids in high school building SoCs. I was off by like an order of magnitude. I mean, and that's actually the biggest challenge that we face is a complete lack of imagination on our part, right? The ideas that we are getting right now in terms of how to use this, they were just sitting there, but because we've been kind of constrained, whether it's due to the way that we were educated or the way that we've just been doing things for so long, we didn't even think about it. And all of a sudden somebody's like, well, why don't we ask it how to do this? Boom, and there we go. So, I mean, lack of imagination is one of the biggest problems we run into. And so for kids who are coming through PhD programs, or my kids are 12, 10, and 8 years old, like, I don't know, but learn how to learn, because things are going to be shifting quickly. And if you're in a PhD program now, I'm pretty sure you're going to end up okay. Yeah, I don't know. It's exciting though. It's I mentioned the professor from NYU he wants to enable biologists to build chips for whatever it is their biology project requires. I think that's incredible. I love it, right?
Hi, have you used ChatGPT APIs? If yes, can you give example how it can be used in ASIC design?
So I almost exclusively use the API. I don't do much of I say ChatGPT, but I'm referring in general to the GPT models. I mostly work through the API. And so we have some Python packages that we leverage to be able to, homegrown Python packages that we've built based on our learnings that allow us to build, to query the model and build the components that we need. But yeah, I like the API better than the chat. So.
The second part is can you give any ASIC design example that you have done?
Like features or like components?
ASIC design related. Examples.
I mean, I referred to like the formal test benches. There's the functional components as well, the verification that we're building collateral like that. It's any portion of digital verification, design verification. We're trying to figure out how to pull this in. So.
I'm an AI novice. AI seems to be only as good as the training data that you have available. And I'm missing here, I may have lots of collateral, but I don't have a textual description of that collateral. I might have a test bench, but I don't have a text description of what that test bench does. Or I may have a multiplier, but I've never written the text that says what that multiplier is. Do we have to send people off to spend days writing text descriptions of our past collateral, or how do we train this engine?
Well, so you don't need to train it. We're not doing any training. We're working off the same model that's available publicly. And then the question I would ask you is, have you given your collateral to ChatGPT and asked it to write a description for you? See where it leads you.
Okay,
yeah.
Thank you.
Just a follow-up on that question. I know you've been working a lot with the ChatGPT API. GPT or GPT-4 was trained on high school textbooks. It has science knowledge, legal knowledge, right? So the code, and also code. So it has an understanding of code, may not necessarily have an understanding of hardware. Do you think GPT or large language models trained on hardware or semi-knowledge would perform better? One. Second, instruct GPT models trained specifically on EDA tasks would perform better. Any thoughts on these directions?
Yeah. So we're not even close to hitting the boundaries of what we can do on the existing models, right? I know there's a lot of conversation around, do we need, Verilog specific LLMs and that kind of stuff? So far, no. I don't know, we'll get the low-hanging fruit and even the medium-hanging fruit, and maybe at some point, but we're not close, right? And the conversations I have with EDA folks is, we have a vision for how we're going to organize these initial experiments, but I'm not going to argue with whether or not that's the right vision for long term, right? But we just need something to organize around, and there's so much low-hanging fruit that we can get. I don't know, once we've solved those problems and we kind of reevaluate where we're at, I don't know what the next level of problem is actually going to look like. And maybe it requires new LLMs, maybe it doesn't. But yeah, we're just kind of, we're using what's publicly available right now, and it's meeting all of our needs. Yeah.
In our research group, we've played a bit around with large language models for Verilog on that topic. What are the kinds of languages that you're actually getting ChatGPT to write? If you're able to comment on that.
Yeah. System Verilog for sure. Python, C, C++, basic stuff. It's pretty good on all that stuff. You have to kind of help it a little bit more with the System Verilog than you do with the Python, but we can get it to where we need it to be. Yeah. Any other questions?
Hi. So I'm curious, what do you think the best case outcomes are over here? So for example, if you look at verification, where do you see 5 years from now, what's the number of people you need to verify a chip?
So I'm biting my tongue a little bit because I've been told I'm not allowed to say certain things. Whatever. The world that we're moving to, my career mission statement that a mentor made me put together 15 years ago is like, where are you going with your career? What do you want to do? And my career mission statement was to verify a chip with one person, right? We're not going to get to that. But instead of having 100 people verifying an SoC, maybe we have 100 people verifying 10 SoCs, or 100 people verifying 100 SoCs, right? The power this is giving to each and every one of us in order to be able to realize the feature sets that teams want in the time scale that they want, we are just barely scratching the surface. So what's the logical endpoint? I don't know. We're not close to it, but there's never been a shortage of work in this industry, right? We're going to be meeting the needs of customers for a long time.
Hi. Nowadays, kids try to choose their streams when they are probably in middle school itself. I want to become a doctor, I want to go to med school, I want to become a STEM, I'll go into engineering and stuff, right? Now that the engineering stuff is automated, even many of the medical stuff is automated, what should I ask my son to study? Or what should I ask my son, what he should start thinking where should he have, yes, you said that, okay, they should start working on creative things, they should be curious, okay, you should start working on STEM projects and stuff. All this is good, but where do you see this going? In the sense, like, I'm seriously confused.
Yeah. I think even before ChatGPT, if you look at the statistics, like most people have, 4 or 5 careers in their working years before they retire. I don't know if this means you have 10 or 12 or whatever it means, but like, the idea that you're going to tell your son to do one thing and then it's never going to change for 40 years, those days are gone, right? We want people that can learn how to learn, that can pivot, right? I'm not an AI person. I don't know the first thing about large language models, but I'm leaning into this to do the work that I'm expected to do right now, right? I don't have a computer engineering degree. I don't have a CS degree. We just need people who can learn how to learn, be curious, and be okay being uncomfortable with a little bit of ambiguity. And I mean, that's outside of that, I can't see the future.
I've heard a lot of comments, just kind of a reply to a previous question about it, is people really need to see these large language models as tools and not replacements.
No, absolutely,
Yeah.
absolutely. And I mean, I've seen other talks where people will say, AI is not replacing people, but engineers that use AI will replace engineers who don't use AI, right? I mean, how many accountants do you know that don't use Excel, right? I mean, it's just a tool that's going to enable you to realize the ideas that you have more quickly and at a lower cost, right? It's just a tool.
Also, this actually caught my eye as well. Is you said before that twice a year you clear your calendar.
Yep.
How much trouble does that usually get you?
I don't get in trouble. Like, I mean, you'll get an email from like 2 or 3 of them, and they'll say, like, hey, why aren't you in this meeting? You're like, okay, I just add it back in my calendar and I go, right? Well, a lot of them kind of disappear into the ether and nobody ever notices. Whatever. And eventually it clutters up and you just do it again. So. All right, thank you, everyone.